Hello again. This is Math 2134 coming to you from the College of DuPage, and the title of this lecture is Marginal Functions in Economics and Business. As always, I encourage you to be an active learner while watching this video. Marginal analysis is the study of the rate of change in economic quantities. So economics are concerned with not only the value of the gross national product, but how does it change? Is it growing or declining? A manufacturer is not only interested in the total cost corresponding to a certain level of production of a commodity, but is also interested in the rate of change of the total cost with respect to the level of production and so on. So let's begin with an example explaining the meaning of the adjective marginal as used by economics. So let's suppose that the total cost incurred by this company in making X refrigerators is given by this equation, the total cost equation, where X is between 0 and 400. And the questions are, what is the actual cost incurred by making the 251 refrigerator, and find the rate of change of the total cost function with respect to X when X is equal to 250, and compare the results. Now here we're talking about the rate of change, and here we're talking about the actual cost, and compare the results. You know what to do. Let's see how you did. All right, well, we say how much did it cost, so we look at the difference between the cost of doing the 251 refrigerators minus the cost of doing 250. So we take this, plugging the number in, minus the whole of this cost. The parentheses are, of course, important. We use calculators to calculate this, and we end up being just short of $100. But the rate of change is the derivative. So we take the derivative of this cost function, and we will get C prime. And C prime is going to be 200 minus 0.04 X. And so we then plug in 250, and we will get 100. And you see those two numbers are very close together, which is what this shows. So the actual cost incurred in producing an additional unit of commodity, given that a plant is already at a certain level of operation, is called a marginal cost. Now that's important, very important for management to know, but as we saw, it's approximated very well by computing the total cost function, the derivative of that. And so for this reason, economists have defined the marginal cost function. So you see, this is marginal cost, this is marginal cost function, to be the derivative of the corresponding total cost function. In other words, if C is a total cost function, then the marginal cost function is defined to be the derivative C prime. Thus, the adjective marginal is synonymous with derivative of. Here's another example, and what we have here is a different total cost function for this company making portable DVD players, and you define the marginal cost function and figure out what is the marginal cost when these things, when you're at these values, and interpret your results. So we're going to take the derivative of that function, and this is what we get for the derivative. And then we're going to plug in 200, 300, 400, and 600. And that means that these are the costs at those different levels of production of making an additional unit. These are the approximate costs. Let's now talk about another marginal concept that is closely related to the marginal cost. So if we're talking about C of X, the total cost, as before, of producing X units of a certain commodity, the average cost of producing X units of commodity is obtained by dividing the total production by the units produced. So that is C of X over X, and that's called the average cost function. We have notation for this. Usually it is called C bar of X, and C bar of X is going to be understood to be the average cost function, or this. So the derivative of this C bar of X, which is this one, which is a quotient, is called the marginal average cost function, and it measures the rate of change of the average cost function with respect to the number of units produced. So here's an example of that. Here's a cost function. We're to find C bar prime, and interpret the results. Okay, so C bar is just going to be C of x divided by x. We do that division and we get this. So this is the answer to part A. And then we're going to take the derivative of this. Now the derivative of a constant is 0, but this is 400x to the minus 1, so this is minus 400 over x squared, and that is a minus sign that's in front of that. So that is the marginal average cost, and we could plug numbers into that if we wanted to. And you see that since there's a minus in front of that and I'm squaring the denominator, it's negative for all values. That means the slope of the tangent line to the curve is negative. And the limit as x tends to infinity of this is equal to 20. That means the more and more you make, you get closer and closer to 20 because your fixed costs get divided out as you make more and more units. Okay, now it's a slightly different question here, and what we're looking at is a different cost function, and we're defining the average cost function, the marginal cost function, evaluate the marginal cost function at 500, and sketch the graph. Okay, so C bar of x is C of x divided by x, so we just do the division and we get this. Now when we go through and take the derivative, we do term by term. So this is C bar of x is equal to this expression. And when we plug in 500, we get 0. Now that means the slope is 0 there at 500. If you look at that, that means that's the minimum average cost, and it starts increasing after that. And so that's the point that you really would like to understand and perhaps be at. We can also apply these to business issues associated with revenue functions. Now revenue, if you're selling something at a unit price of P and you sell X units of it, so the revenue associated with that sale of X units is P times X. But P in turn often is a function of X itself because this is a supply and demand situation. And so you see the revenue at x is equal to px is equal to x f of x, where f of x is the demand function. Now the marginal revenue then gives the actual revenue realized from the sale of an additional unit if the sales are already at a certain level. But we defined then in the same way as we did before, a marginal revenue function is r prime of x. And notice if I'm taking r prime of x, it's going to be the product rule. Okay, let's work through one of these then. Here you have the demand function as P is equal to minus 0.2x plus 400, where x is between 0 and 20,000. So you define the revenue function, the marginal revenue function, and compute R prime at 2,000 and interpret your results. So the revenue function is always going to be P times x. But this is the x. And here is the P, because P was equal to this. So we distribute and we get this, and that is our revenue function. R of x is equal to this expression. Now we're going to take the derivative with respect to x, and we get this. And we're to plug in 2,000, and we get 320. That means the actual revenue to be realized from the sale of the 2001st loudspeaker is approximately $320. Our final example of a marginal function involves the profit function. The profit function is revenue minus cost. It could be positive or negative. And so the marginal profit function is the derivative of that. And that measures the rate of change of the profit function and provides us with a good approximation of the actual profit or loss realized from the sale of the x plus first unit of the commodity, assuming that the x unit has been sold. So here's an example. Here's your cost function, and we're using the profit function from, I think, example 5. So r of x in example 5 was equal to this. So p of x is equal to r of x, this r of x there, minus the cost function x, which is up here. And notice it's minus the whole of the cost function. So we simplify that and we say, oh, p of x is equal to this. And that's the answer to part A. Part B, we'll take the derivative of that because we're looking for the marginal profit function, P prime. And so this is P prime. We just take the derivative of this with respect to X, and we get this, and we can plug in 2,000 in part C, which we're supposed to do, and we get 220. Thus, the actual profit realized from the sale of the 2,000 in first loudspeaker system is approximately $220. And the graph is here, and you can see that, gee, there is a point where you are maximizing profit, and that's something you want to understand and perhaps be near to. We will continue this discussion in 20.1.